Hi, this is Mr. West, and today we're doing a Khan Academy tutorial on find the mistake in one-step equations. Before you watch this, if you haven't done the one-step equations for addition, subtraction, and multiplication and division, I'd encourage you to do those and check out the videos if you need help with those. So I'm going to kind of jump right into it, and I'll do my best to explain it in case you haven't seen those or done those yet. So with this exercise, we're just going to go through the equations, how they're set up and calculated, and see if there's any mistakes. So let's go ahead and look at this one. We see that we have j divided by 10 equals 80. That's how you read that. It's divided by, even though it looks like a fraction. Fraction and division is the same thing. And as I talked about in my other videos, the important things, for solving equations is by using inverse operations. Struggle with writing here. So we have inverse operations, and the inverse operations just mean if we have, for example, addition, the inverse of that is subtraction. That's how we undo it. And the same is true the other way around. Now for multiplication, we're going to undo multiplication with division, and the opposite of division is going to be multiplication. So in this case, we're noticing that our variable, j, that's our question mark, our unknown, is being divided. So if we want to undo that operation, we would need to multiply by 10. And you can see that's the step that's taken place in the setup phase. And then in the calculating phase, the j is going to be by itself because the 10 cancels with the divide by 10. And we just need to do on the right side 80 times 10 when that is going to be 800. So everything's done correctly on this one. Gabby did a great job, and we can go ahead and select that and move on to our next question. Next one, we have some fractions. Don't worry about the fractions, okay? That's not such a big deal. We still just need to approach it in the exact same way we would with anything else. So we're first going to analyze what is happening to our variable. Our variable is being added to 3/4, okay? And as we said before, if we want to undo addition, we need to subtract. So we need to subtract 3/4 from both sides. You may notice something here. Check this out. So we're supposed to be subtracting 3/4 from both sides, as I blur it out completely. And on this right side, we're adding it. And that is a no-go. You can't do that. You can't subtract from one side, which he should have done. Oscar should have done, okay, because that will cancel out the 3/4, leaving with just m. But on the right side, we need to subtract also. Think of equations as a balance beam or a balance scale, however you want to say it. And if we subtract from one side, and if we do nothing on the right side, it's going to not be balanced, and it's going to be not a true statement that says equals. The easiest example is if we have 10 equals 10, and we subtract 2 from one side, 8 doesn't equal 10. That's wrong. Okay, we'd have to subtract 2 from both sides so that it stays balanced. So we can't add to one side and subtract from the other. It's going to make one side go up and one side go down. So we need to make sure we subtract from both sides. So our error is in the setting up phase. Okay, we did not subtract from both sides, and that's the problem. Okay, moving on to the next one. You don't really need to know about calculating. You just need to see what is the strategy this person's using. Okay, so we see that we're adding 12 here to my variable, understanding my variable and what side it's on. In this case, it's on the left side. And we need to do the opposite of what's happening to it. So the opposite of addition is subtraction. So that is done correctly. Those are going to cancel out. We're going to be left with just n. Left side good. Now we just need to see, okay, does 18.3 minus 12 equal 5.7? I'm thinking it doesn't. Okay, I'm thinking it equals 6.3 instead, right? Just to check it, we subtract 12. I need to make it 12.0 so I can line up my decimal. I get 3, 6. I messed up. There. So I get 6.3. That was supposed to be 0. 6.3. So my calculating phase was done incorrectly. But the setup was great. The setup's the most important part. Okay. Last one. We're going to analyze what is currently happening to my variable. In this case, we're looking here. What does that mean? 3x means 3 times x, okay? And we're getting away from the x for multiplication because that just looks too confusing, okay? So 3.x means multiplication, 3x means multiplying. So we're going to divide, and that's what this means right here, by 3 to both sides. If we're multiplying by 3, we're going to do the opposite, and we are going to divide by 3. And it's very important that you do that to both sides. Okay, so we divided by 3 to both sides, as they showed here. That undoes the multiplication, and we're left with just x. And now we have 4.5 divided by 3. Does that equal 1.5? Yes, it does. A way to check that, and you can watch my long division videos or my decimal division videos if you need help. We have 1.5. We can move the decimal place first, and we have 45 divided by 15, and that is going to be 3 as my answer. So that is correct. Whoops, I was supposed to divide by 3. Not the other way around. So we have 4.5 divided by 3. Well, I checked my answer. So we have 3 goes into 4 one time, and that's 3. Then we have the 1 left over. There's a decimal there. Drop down to 5, and that goes in 5 times. No remainder, so I'm good to go. So 1.5 is the correct answer. This person did it. Ofrad did everything correctly. Good job. And that's all there is to it. I hope you guys enjoyed that video. Make sure to check out more videos like this on my math YouTube channel, Wes Explains Best. And I look forward to seeing you next time right here. See you then. Bye.